Cloud Native Live, where we dive into the code behind Cloud Native. I am Sondipon Panda. I am a CNCF ambassador and a member of technical staff at DevZero, and I will be your host today. Every week, we bring a new set of presenters to showcase how to work with cloud native technologies. They will build things, they will break things, and they will answer your questions. In today's session, I am stoked to introduce Urs and Tal, who will be presenting on uh, how Mirror D eliminates dev environment chaos. So just a quick reminder that this is an official live stream of the CNCF. As such, it is subject to CNCF code of conduct. Please do not add anything to the chat or questions that would be in violation of that code of conduct. Basically, please be respectful of all your fellow participants and presenters. Uh, with that, I will hand it over to us to kick off today's presentation.
Sure. I think we can do a quick intros before we start getting into making and breaking things. Hopefully, just making things and no breaking things. But hi, everyone. Thanks for joining the stream today. My name is Arsh. I work as a DevRel engineer at Metal Bear, which is the company behind MirrorD, which is an open source tool which we'll be talking about in this stream. I am also a CNCF ambassador, and I've been a contributor to the Kubernetes project in the past. I'm joined by Tal today, and I'll let him introduce himself before we go into this stream.
Hi, yeah, so my name is Tal. I'm one of the developers of MirrorD. We write MirrorD in Rust, so I'm mainly a Rust developer these days. Yeah, I work both on the parts of MirrorD that run in the Kubernetes cluster and also the parts that are outside of Kubernetes. Yeah, I've been a part of the cloud native community for a couple of years now. Gave a talk in KubeCon Paris last year. So yeah, that's it.
Cool. We have a lot to discuss, so I'll just jump right in and start talking about what we're going to talk about. So the title of our talk is One Environment to Rule Them All, which is a Lord of the Rings reference for those who are unaware, but I mean, not getting a Lord of the Rings reference is pretty rare. But anyways, coming back to the topic, our talk is going to be about dev environments and how in recent times there have been like a sprawl in the number of dev environments organizations have. And we'll talk about how MirrorD helps you reduce that and lets you use a shared staging environment for your development needs. Before we talk about any of that, I think it's important to be on the same page about what we mean when we use the term dev environment, right? So it's a term which gets thrown out a lot and it's pretty self-explanatory. It's like an environment which developers use to write code. But I want to just see how historically this has evolved over the years. So like earlier, like when, things were much more simpler, developers would just write code on their code editor, and that code editor basically could be called their development environment, right? You would run code locally and you would write it locally and just ship things as they came. Then when we switched to VMs, you would sort of sometimes SSH into a VM and then use that to test your code or things like that. And then you could say that VM was part of the dev environment of the developers. Then with containers, things changed even more, and we started seeing Docker Compose files, which would run containers locally, and you would run your code via them. And that sort of expanded the scope of dev environments, and containers were introduced in the mix. From there, we went on to starting to deploy these, and that started to shake things significantly for dev environments, because now you were at a point where, like, how do you run these containers which run in Kubernetes on production locally? And it is really important to run them locally in the same way you run as production, because if your local setup does not look like your production setup, then there'll be a lot of bugs which you will not be able to catch until, like, you hit staging or production environments. And the earlier you catch bugs, the sooner you can fix them without going through the entire dev loop again and again. So when Kubernetes started coming into picture, the dev environments which developers, cloud native developers, especially, developers who were working with microservices based applications, the kind of environments they started using for development started to vary a lot. Some people did not move from Docker Compose or running containers locally, and this thought it's just a good idea to bridge this gap via CI pipelines or staging or test environments. But some people started provisioning local clusters using Minikube or Kind and started using them for development. Other approach was like provisioning a shared cluster. Other approaches included like provisioning a cluster and then allocating different namespaces to different developers to deploy their code during development, or sometimes even going to lengths as far as provisioning a cluster per developer for development. So you see there are a whole lot of options and approaches which organizations started to take when this shift from containers to Kubernetes, just running containers to running them on Kubernetes in production started happening. So now we work in this space and we talk to a lot of developers and a lot of companies, and we have seen like a few common patterns which companies are at when they work with these dev environments. And I wanted to talk about some of those patterns and touch upon why they are not the most optimal solution out there. So one common thing is just local setups. And when I say local setups, they could mean anything from Docker Compose, running your containers locally during Docker Compose and using that for development, to some scripts which spin up like a Kind or Minikube cluster and then deploy the app, and then you sort of do some port forward or SSH to, so not SSH, you sort of run your code, you run your local code in that local cluster. And these approaches have a couple of problems. One, first of all, they claim to look like production, but they never look like production, because you can never replicate the configuration you're using for your clusters locally, because even if you're using something like Minikube or Kind, it is still not the same, right? You would still not be able to deploy all the things which are there in your production cluster, including service meshes or some other configuration files, or sometimes even cloud provider specific services on your local machine. So these setups never match the production setup, and because of that, developers are still developing in an environment which looks nothing like production, which means they are still relying on CI pipelines and they are relying on staging environments to get that final validation that their code will actually work when they submit that pull request. The other problem with this approach is that it puts the entire burden of maintaining this dev environment on developers. It puts the burden of debugging this dev environment when things go wrong on developers, right? Because now you can have scripts which the DevOps team creates, but when things go wrong, developers either need to familiarize themselves with Kubernetes concepts and debug these things themselves, or they're dependent on the DevOps team. And the DevOps team is now managing every individual developer's local dev environment in order to support them in their development process. All of this just leads to more complexity in the way your team develops, and it really makes for an inefficient development experience and a poor development experience. And your developers end up spending way more time setting up and configuring their dev environments than they do actually working on the product. So these are some of the problems with local setups. Let's talk about the cloud setups, which we talked about earlier, and some problems which teams face when they do that. So one common setup, I mean, it's common depending on the scale of your organization, but is just letting developers provision clusters as per their needs, right? So you start provisioning a cluster per developer, and that makes sense if you want to isolate your environments. But the problem with that is that it's a really, really expensive approach. Provisioning a cluster per developer means you end up spending a lot of money on cloud bills, because now you're provisioning a cluster per developer, and these clusters sometimes are running for a long time because developers forget to shut them off, or they get over provisioned and things like that. So this is an approach not a lot of organizations take, but we have still seen this happen. The other more common approach is taking a cluster and then somehow sharing it. So isolating it via namespaces, or using some other tools or products to just separate out the cluster into different namespaces for every developer. And the problem with this approach is that, let's say you have developer A and developer B, and both of them are working on the same application, but different microservices of that application. When they are testing the code they have written, they still need to bring up that full application. And in order to do that, they would deploy a copy of that application to their respective namespaces. So you can see how even with this approach, you have the same app deployed twice on the same cluster, just in different namespaces. Still duplicating services across your cluster. You're still duplicating databases and other things, just in different namespaces. So while namespaces give you isolation, they do not stop this duplication of services. And why is this duplication of services bad? Because at one point, to support all of these copies of your application, you will need to increase the amount of resources provisioned for your cluster, and that also ends up adding to your cloud bills. So now that we have talked about these different approaches and the problems they have, I want to sum up before we start to talk about what MirrorD is, why we built it, and how it solves these problems. So far, the problems we have seen is that one, approaches are either nothing like production, and which leads to developers just struggling to get that confidence that their changes would work, and just relying overly on CI processes and testing, and just things breaking sooner to your shipment, like sooner to the shipment phase in your dev lifecycle. Or the other problem which we have seen is just high infrastructure costs in terms of over provisioning resources or having multiple clusters or namespaces. All of this also leads to a maintenance burden on your DevOps team, because the more environments, the more namespaces, or even clusters your DevOps team is managing or platform team is managing, the more the more they have to focus on solving each developer's individual environment specific issues instead of just one shared environment. So now that I've laid the foundation for all of this, I would like to hand it to Tal, who will explain like why we built MirrorD and what MirrorD does, now that you have all this context.
Cool. Yeah, thanks, Ars. So, yeah, I think first of all, like the first interesting thing about MirrorD is that it was created out of personal pain of our of like the two founders of this project, right? So they themselves were working in a team that was creating and maintaining microservices that were running on Kubernetes. And at some point, they just realized that that dev experience is unacceptable. So with like basically any workflow that isn't Remoco, in order to like test your code, in order to run it while you're like during your development process, you have to go through like a bunch of setup that is either expensive, inconvenient, complicated, or all of the above. And was like so far away from the ideal development experience, right? So when I say the ideal development experience, then I think about just you're writing your code in your IDE, right? It's all there. The language you're working on, whether it's Go, Python, whatever, has some really good like debugging tooling, but you can't use any of it, right? You have to like with the traditional cloud native DevX, you have to deploy your code somewhere, do a bunch of setup, and even after all that complicated setup, all you get is now you have to like look through logs, and if you didn't get what you were looking for, you have to go through this whole process again. Instead of the good old, yeah, just click the debug button in your IDE, go through breakpoints, like have like debug like a human, like have some nice developer experience. And that's what MirrorD sets out to do. Basically just deliver that sane developer experience for cloud native as well. And yeah, but what it does, so like how it delivers that sane developer experience is it basically just lets you run your code in your IDE, even though it's a microservice that's written to be run inside a Kubernetes cluster, and your code running in your IDE locally in your machine will just work. So even though you're probably thinking like, no, my code needs it needs connectivity to other microservices in my cluster. There are a bunch of environment variables. that my application needs to run, and I don't have all those on my computer. It needs some file, whatever. So all of those resources are going to be available to your service that is running locally. It will basically run locally in your IDE or on your system and think it is running inside your cluster, because it will actually get connected to the cluster. I see there are a bunch of questions or comments in the chat. Should we do them now?
Yeah, I think if we see some questions, let's take them right now. Can you bring them on screen, Sandeepan?
Yeah, sure.
Yeah, so we do have extensions for VS Code and basically any VS Code fork. So cursor, whatever you're using, the VS Code extension is going to work on that. And we have plugins for IntelliJ-based IDEs, so Golang, PyCharm, any of the main JetBrains IDEs. Cool. So I think it's back to you, Arsh.
Okay. I see some more questions, but don't worry, we'll take all of these questions like before we end the stream. But I think we have done so much talking, and it'll be nice to share my screen and like show people actually how Miradi works, so that you get a lot of context about all the things we have talking about. So before I actually share my code editor and show you how Miradi works, I just want to give you an overview of the demo you will be seeing, so that we are all on the same page. So let me first just share one quick architecture diagram about what the demo app looks like, and then we'll go into the demo. So I've shared my screen. Cool. I think please let us know in the chat if like the font is too small or you can't read anything. But for this demo, we'll be working with an application which is meant to mock what a microservices based application could look like. So we have a couple of services. One of them is the IP visit counter. Then we have another service which is the IP info, and then IP visit consumer. And what this application basically does is that when you enter the URL for this application, when you send a request to this application, it basically counts the number of times it has received a request from your particular IP, and then it returns that count back to the user. And behind the scenes, how this works is that, first of all, it saves the IP to Redis, and then it gets some extra info about the IP. So we have like a message which it shows for the IP. We'll see that. And then finally, it sends a message to Kafka, which stores it in a consumer and just uses it for logging purposes. But what I want you to gather from this diagram is that we have a couple of microservices here, and we also have Redis and Kafka. Now, if you were developing this application locally, and let's say you're working just on the IP visit counter service, as a developer, this is really tough. And this is the problem which is inherent to microservices-based application, that just working on your isolated service isn't as easy as before, because now you would need to bring up this Redis locally. Then you would have to bring up the IP info service, then maybe even the Kafka queue if you want to, test that part of the code. And all of this puts the burden on the developer to set up their own environment. And they might not, even if they have the information to set this up, it's still wasting time which could have been spent during development. And these are things which I feel like a solution which is for dev environments, for cloud native applications, should address. So now that you have an idea about the architecture of this application, let us go into the demo, and I'll bring up my code editor and share that with you all.
While you're setting that up, I'll just mention one more thing that I forgot to mention before. So one very nice aspect of how Miradi works is that thanks to the fact that you're just running your code directly in your system, it completely eliminates the need to containerize and do any deployment to Kubernetes during the development process, which, depending on the project, can save a lot of time.
Yep. So the whole idea is that now, like Tal said, I will develop this particular service, which is the IP visit counter service of this application, and I will not have to go through, any redeployments or any CI pipelines just to get validation that the code I've written is working, and just to make sure that the service still interacts well with the other services. And traditionally you would have to go through CI setups, because that's where you would bring up the other services and the databases and get that validation that the code you have written for this particular service is not breaking the application in other places. Before we start to see that, I just want to show you what the application looks like. So if we send a request to this particular URL, which is playground.metalbear.dev, you'll see that we get a response where we see count1, which is basically how many times I have pinged, how many times I've sent a request to this service from my particular IP. And here we also see a message which says remote is fun, and then there's a hi appended to it at the end. Cool. If I send another request, you'll see that the count gets increased by 2. Now I want to, even before we do anything, I want to see how this would look like when I develop this with Mirrord, right? And the way to do that is that, first of all, the idea with Mirrord is that your team has a shared staging environment where the application is deployed, and then every developer can run their code locally while getting traffic, environment variables, and all the configuration from that shared staging cluster. So if you see here that if I get all the deployments, you'll see that in my cluster, I have all these services deployed. So I have the IP visit counter, consumer, I have the Kafka and the Redis services all working in my cluster, and none of this is running locally on my machine. Now, if I want to mirror traffic which is coming to my service on the cluster to my local machine, I can use Mirrord, and that would help me test out the code I've written and see how my locally written code behaves. So for that, the first thing you need to do is either install the Mirrord CLI or the different extensions we have for different code editors. So I'm on VS Code and I've installed the Mirrord extension here. And once you have the extension installed, you'll see a small, I think it's not visible. Okay. My name is covering it, but on VS Code, you'll see a small section below which would say Mirrord. And if you click that, this pop-up will show up and you can enable the extension. And then you have to select active configuration. So that configuration lives in a JSON file, and it's called the Mirrord.json file. And since we'll be working with the IP visit counter service, I'll choose the JSON file for that. I won't show you the configuration right now. We'll get to it later. But first, I just want to show you the magic of Mirrord. So now that we have Mirrord enabled here, I can go to run and debug. And I've set some breakpoints here, and I'll show you why I've done that and what that leads to. But basically, we can continue developing this application as we would locally, if assuming everything as we would locally. So I just click run and debug, and here you see a new version of Mirrord is available, and I won't do the update right now. But you see Mirrord is asking me which target I want to select in my cluster. So since we are working on the IP visit counter service, I select that particular deployment. I can also select individual pods, but in this case, I'm just going to select the deployment. And what this basically would do is that all the traffic which would come to these pods, Mirrord would mirror that traffic to my locally running process as well. So I select the IP visit counter pod, and here you see that Mirrord is starting our session. And once that session is active, which should be any second now, you see that our main function gets executed, and we already hit our first breakpoint, which is loading the config. So I'll step into this, and you see here that we first of all create a bunch of environment variables, and then we read them and populate them in this config which we return here. So if at this stage I inspect this config variable which gets returned, you see that I have populated all of these variables, and none of them have been populated from my local machine because I have not set these values on my local machine. So the Kafka topic name which gets populated is not there on my local machine. This response file you see, app.response.txt, is not there on my local machine. And I'll copy this value and just show you that it's not there by trying to see its contents, and you see that there's no such file or directory on my machine. And this is take note of this, because now that once we like exit out of this function, I'm going to hit my second breakpoint, which basically reads from this file. So here you see that we try to read from app.response.txt, and the response string that we got here, I think, yes, yeah, the response string we got here is remote is fun. So this was a file which was present in the Kubernetes cluster, which thanks to Mirrord, our local process was able to access, and then it was able to read this text remote is fun from that file. So you saw, just like with this minimal setup, just with having the extension and just setting the config, we were able to read environment variables and read all the files which are in our cluster without having to do this, without having to set things up locally. Now I'm gonna go here a bit above in the code and set another breakpoint at when we first, get the client IP. And now what I'm gonna do is just first I'm gonna let this process like run beyond the previous breakpoint and wait to see that the process is now running locally. And now when we send a request here to the same endpoint that we used last time, this request would hit our cluster. It would go to the service which is in the cluster. But thanks to Mirrord, it will also get mirrored to this locally running process, and we would hit this breakpoint which we have set. And you see, as soon as I send this request, my breakpoint gets hit. And if I try to, just go one level down, you see that I can read the IP from which I send the request. So this is what traffic mirroring in Mirrord is, and this is like the whole concept which makes local development feel like it's happening in the cloud, allowing you to test your changes in a realistic environment, while you not having to build any containers or deploy anything or do any sorts of hacky connections with the cluster. One important thing I also want you to take note is that we got a response, right? So this response was sent by the service which is there in the cluster. So our locally running process is like still at this breakpoint. We haven't allowed it to continue, but the service which is there in the cluster responded, and that's the response we are seeing here. I'm going to stop this now, and I'm going to show you the Mirrord configuration file I talked about earlier. So in this file, basically, we have just enabled the features we want to use. So since we were reading from the file system of the cluster, I've enabled the read mode. And then here under networking, I have enabled the mirror mode for incoming traffic. So that means whatever traffic is coming to the cluster gets mirrored to my locally running process. Before I get to the even cooler parts of Mirrord, I just want to check the chat for a second to see if anyone has any questions so far. If you do, now would be a great time to ask them.
I see you have some questions.
Yeah. So regarding like special security configurations of Kubernetes clusters, should be fine. We like Mirrord runs on a lot of like very different and diverse clusters, many organizations, and maybe you can share like your specific concerns or like what you think might not work because of those special security configurations, but basically most of the time your local application, thanks to the Mirrord agent that we'll maybe talk about later, is able to do whatever your workload is able to do. So it's usually not affected by that kind of change to configuration.
Yeah, the idea is that the cluster which you're already using for staging or any testing environment, you should be able to use Mirrord directly with it. So even if you have like some extra security configuration or anything like that, that should not affect your usage of Mirrord with that particular cluster. But like Tal said, if you have any specific like questions which you want to discuss, you can join our Slack community and ask us questions there. You'll find all the links on our website, which is metalbear.co. Cool. So coming back to the demo, here what we saw was the mirror mode in Mirrord, where any requests which come to the cluster get mirrored to the locally running process. But there will be instances where you want to test the response of your code as well, right? So here we saw that the response was still being sent by the service in the cluster. So when you want to test the response of your code as well, then we have a different mode, which is called the steal mode, in which case the request which comes to the cluster gets stolen completely and gets like sent to your locally running process, and the service running in the cluster has no idea that the request was there. So this has two benefits. One is it allows you to test the response of your code, and secondly, it allows duplication of changes in your cluster. So let's assume you had the service running in your cluster which was making some changes to your other services or your database. If you were using the mirror mode, then because of mirroring of that request, you would see those changes twice, once being made by the service which is in the cluster and the other time being made by the locally running process. Now, if you steal that request, the service which is in the cluster does not get the request and makes no changes. And it's only the locally running process which makes those changes. And at the same time, you're able to test out the response of that code as well. So I'm going to change this mode to steal. But what we are also going to show you is that that Mirrord allows multiple developers to work with the same cluster safely, right? So if I start stealing all the requests which are coming to this particular service, then I might end up breaking the cluster for Tal or other developers on my team. And at the same time, I don't want that to happen. I just want to test out my code changes with my requests. So I can filter out the requests which come to the cluster. So I can set a filter, and any requests which match those filters will be stolen by Mirrord to my locally running process, and the requests which don't match that filter would just continue working as normal in the cluster. So I'll add a HTTP filter here, and then I'll add a header filter. Oops. And then I'll just set a header of xpg tenant, and any requests which match my name, which is Ash, by the way, in case you didn't notice, would get routed to my locally running process, and all other requests would not be touched. Cool. So let's see this in action. Now that we have updated our Mirrord config, I'm going to clear out my terminal, going to run and debug, and click run and debug. I'm going to update my Mirrord version as soon as this live stream ends. But till then, we're going to work with this version, and I'll select the same deployment as selected last time around. Wait for this to function, and we hit our first breakpoint. I should actually have probably removed these, but let's just skip this one and skip this one as well. And now we're just waiting for our process. So we see that our service is running and serving on this port. But what we're going to do now is that we are going to send a request to the same endpoint here. And you'll see that we get a response and our breakpoint does not get hit. This is totally expected because if you remember, we set a HTTP filter and this request did not have that particular filter. So now I'm going to send a request which has that filter, and I'm going to add that here. Now, when I send this request, it would be intercepted by Mirrord and stolen by Mirrord, and you see that we already hit our endpoint. Now, one difference you'll notice is that we do not see any result here, whereas when we were using the mirror mode, we instantly saw the response of our request. This is because that response was being sent by the service in the cluster, and since now we are stealing the request, it's only being answered by a locally running process, which has been halted by our breakpoint. So nobody's answering this request. So if I release this and continue it, you'll see that I see a response here. What I'm also going to show you next is that, that we were able to steal traffic and filter, but what this enables is allow you to, test your locally, like local changes you make to your code. So here that you see that we get our response, the text we are seeing here is remote is fun and then a hi at the end of it, right? So I'm going to make a very simple code change, and I'm just going to change this hi to hello CNCF. And but the I want you to imagine that you're working on your application and you have made some complicated changes. You fixed some really important bug or added some new functionality. Now traditionally, if you wanted to test that functionality, what you would have to do is commit your code, then wait on CI pipelines to run, and build container images, deploy to a staging environment, and all of that stuff. And only after that you would get the validation that the bug you have fixed has actually been fixed, or the feature you have added is working. Whereas with Mirror, when you write that code, as soon as you write that code, you can get the same validation which CI gives you, or which deploying to a staging environment gives you, immediately as soon as you have written that code. And that allows developers to iterate really, really fast, because it cuts down the time, and it makes CI something, you just go through as like a final check for that final surety that things won't break, instead of relying on CI to constantly test and get that validation if your code would work or not. You can get that validation much earlier in the development lifecycle, allowing developers to be more efficient. So we made that code change, and I'm going to send another request, and our breakpoint gets hit again. I'm just going to release this request, and we are going to wait on the response, and we should see our updated response here. Any questions so far on the steal mode and mirror mode of Mirror? So you see here we get the response, and the text, instead of saying remote is fun, hi, like it said, it says hello CNCF, which is the change which we made locally to our service. So I know this might have been a lot to take in, and I'm just going to do a quick sum up of what we saw. So we saw two modes in Mirror. One was the mirror mode and the steal mode. Both the modes allowed us to run our service locally on our machine while getting configuration, environment variables, files, and traffic from the cluster to our locally running process. This allowed us to write code and run our local code in an environment which is exactly like production, so giving us the validation that the code we have written is working, while also taking care of the headache of us having to deploy or set up this environment, because we are using the services and the databases and everything which are there in the staging cluster. So we don't have to do any setup locally, and we just leverage things which are there on the cluster. One final thing we also saw was how Mirror allows multiple developers to share the same cluster and not affect each other's work by setting HTTP filters and just getting the requests which are specific to you and meant for you. I'll hand it over to Tal if he wants to add anything to this demo. But after this, we are going to see an architecture diagram of how Mirror works behind the scenes, which should make things even more clearer.
Yeah, so maybe the only thing I want to add about the demo is the nice thing about mirror mode, which is the default mode of Mirror, is how it allows you to test your code using that shared environment in a way that's completely non-intrusive and like non-disruptive of your team's work. So you can, when you mirror the traffic, you kind of like, you're shadowing the system, right? You're kind of seeing how your local service, so the code you changed on your system, handles actual traffic from the shared environment without affecting the shared environment, because it will still be the deployed code, the tested code that's deployed to the staging environment that runs there, and that means you can test broken code, right? You can in a very early stage of your development, you can already run your code in very real conditions, because the code that you're testing doesn't get deployed anywhere. You're not changing the state of the cluster. You're not affecting the user, like the other developers. So that's a really nice aspect of it that we got to see a bit in the demo.
Yeah, I think Tal mentioned something really important, which when we tell people about Miradi, their first concern is that if I use it with a staging cluster, what if I break that staging cluster? That concern gets totally mitigated with Miradi because it allows you to safely test out the code you have written while ensuring that the cluster is still available and does not get broken for other developers on your team. Can you choose multiple services to mirror? Yes, you can choose multiple services to mirror, and you can run a different session for each service. So that is totally
Yeah,
possible.
exactly. I mean, I guess for multiple services, you'll have multiple projects or directories or whatever on your machine, right? So you can just start a mirror D for each one of those services, and for each one of those, you specify the right target, and you can run them one at the same time, and you can even have those services communicate with each other via the cluster. So yeah, it's all supported.
Yeah, so we showed like a really simple use case with the VS Code extension, which might have given the impression that it's for like single service development, whereas that's totally not the case. Like we have users using this in like really complicated applications where like 50 plus microservices and they're interacting with each other, and you can totally run multiple services. You should try out the Miradi CLI, and we have the same functionality which we saw here can be achieved via the CLI, and that allows you to target different microservices and run those processes and mirror traffic for those services to your local machine. I think let's talk about like how Miradi was working behind the scenes, and Tal can give you a really good idea about that. And I'll share my screens just so that we have like a diagram to look at while Tal explains us how Miradi was working
Cool.
under the hood.
Yeah, okay. So this is where it gets a bit technical. If you have any questions, just write them in the chat and we'll try to answer them. So first of all, yeah, if we zoom out a bit, like the Miradi has a couple of main components. So the first one, closest to you, is the Miradi layer, which technically speaking is a dynamic library that Miradi injects into your service. Okay, so Miradi has the CLI, which is the binary you run. And it has the plugins, right? The IDE extensions plugins. Those just use the Miradi CLI. So that's the like application we distribute. You can download and use Miradi via that CLI, or via the extensions that use the CLI. And when you run Miradi, Miradi starts your service. So it runs your code, whatever that might be. So if you're working on Go, it will probably run the Go binary with Go run and then your main file. So the Go binary will compile your code, right? So Miradi will run whatever you're running, but it will inject, it will load our dynamic library into that process. And that's the Miradi layer. That's the dynamic library that gets loaded into your local service. If you don't know what a dynamic library is or what all that means, don't worry about it. You don't have to know or understand any of that in order to use Miradi for debugging and running your code. Not every developer that develops cloud native code has to deal with dynamic libraries or code loading or anything like that. So don't worry about it if you don't understand it. If you are interested, we have a bunch of technical blog posts on our website that explain how we do that loading of that dynamic library into the process. Okay, so those are the components that run on your system, on your computer. And then there is one more very important component that runs inside your cluster. And when I say your cluster, it's just whatever cluster your kubeconfig points to. So Usually you'd be connected to some dev staging cluster. So whatever is configured in your system, Mirror-D will create its agent pods in there. So the agent that's deployed as a pod inside your cluster, and that pod will be created on the same node as the target you choose. And the purpose of that agent is to get access to all of the resources your service needs, and make them available to the local components, right? So when a flow like we saw in the demo happens, right? When your local service tries to redefine, like we saw in the demo R showed us, what happens is, so your service makes a call to redefine. The Mirror-D layer catches that call and forwards it into the Mirror-D agent pod inside your Kubernetes cluster. The Mirror-D agent pod accesses those resources, so the file or whatever your local service tries to access, and makes that data available to your program by sending it back to the layer that in turn makes it available to your local service. So yeah, this was just a bit about like how it works behind the scenes. You don't have to understand this in order to be able to use Mirror-D. But again, if you're interested, we have a lot of technical talks and technical blog posts that explain all of that. More technical aspects of how we implement this tool.
Yeah, while Tal was talking, I was just finding the link for the blog post, the particular blog post Tal was talking about, and I couldn't find it. But Sudeepan, if you could just share the general blog, I think we have like a lot of blog posts there. I think I found this one, which it might be relevant to how Mirror-D works. And we'll have the link up on the screen for everyone to view. But this was a bit about how Mirror-D works behind the scenes. Now I just want to, it's gotten like we've seen the demo, we have understood how it works behind the scenes. I just want to sum up like why, and like in case drill down on what I said at the start and sum up why you would use Mirror-D and what are some of the benefits of using Mirror-D for your development needs. So first of all, I think we all can agree, anyone who has worked on a microservices-based application, it is just really complicated and just getting wilder every day with the number of services your application has and the repeated context switching between working on one service and the other. I think cloud native developers the burden needs to be relaxed instead of being overburdened by additional needs like managing their own development environments, debugging them, or setting things up locally. So Mirror-D takes care of all of that for you by making sure that your DevOps or your platform team just has to manage one Kubernetes cluster. It could be your shared staging environment, it could be a shared development environment, whatever you want to call, but basically one environment to rule them all. Do you see how I came back to the title? Yeah. But yeah, you just have to manage one environment and then connect. All your developers can use Mirror-D to connect to that one environment when they're writing code, and they'll get access to a production-like environment where they can, test out their code changes and get that feedback immediately instead of waiting for sometimes hours on CI loops to, build containers and deploy to get that validation that the code they've written is actually working or not. That is one of the biggest benefits of Mirror-D, is that because of all of this, it allows dev teams to really just iterate fast and ship features and bug fixes faster. The second benefit is that it significantly reduces the costs and the money you spent on dev infrastructure. So if you are spinning up multiple clusters, or even if you have multiple namespaces on the same cluster, you can significantly reduce those costs. And we have seen our users do that with Mirrord, because with Mirrord, you are able to safely share a single Kubernetes cluster instead of, provisioning clusters, or, just creating replicas of your application on different namespaces. So the second benefit is that it can dramatically reduce your cloud costs. And the third benefit is just a great development experience, right? Mirrord enables developers to work as they would locally, using the same familiar tools, using the same debugger and everything, while Mirrord takes care of the headaches of doing the complicated stuff of connecting to your cluster, giving you access to real configuration, real files which are there in your cluster, all the services. So it just allows developers could just pretend Mirrord is not there. Once you switch it on in the co-editor, or once you run it via the CLI, you can just continue developing as you would have been locally, without having to deal with Kubernetes or any of that stuff. And on the DevOps or the platform engineer side, it also eases the burden of maintaining multiple dev environments, of troubleshooting these dev environments, and always being on support for developers, and just instead taking care of one dev environment or one staging environment. And if things break, you just have to fix one environment instead of debugging individual issues of individual dev environments. So those were some of the benefits of Mirrord. And yep, I think we are about to conclude the webinar. I really hope you found this useful. We are still here, so if you have, I think we have 10 minutes, right? So if you have any questions, please feel free to ask them. We are happy to talk about Mirrord more. And let us know how you found out, if you like the stream, did you like the demo, or if there are things you would like to, we plan to come on and do this webinar again. So if you want to see a different demo or some particular use case, we'd be happy to show that to you the next time around.
Yes, and be sure to check out when this gets uploaded to YouTube. So I will be sure there will be some questions there as well too. So check out the comments there as well.
Do we have any unanswered questions on the YouTube chat or somewhere else?
I don't see as of now, but I was particularly interested in knowing what kind of teams or companies usually benefit most from adopting Mirrord.
Yeah, so we see the larger the team, the more benefit you will get probably. But it's already super useful for individual contributors, even people just working on a system by themselves. And so because already even if you're working alone on a system, just having being able to debug your code with the debugger, setting breakpoints, that kind of stuff, not having to duplicate any resources, any setup. So even for an individual contributor, or even for just a single developer working on a system on their own, it's going to be useful already. But once you start collaborating, and once you start having more microservices, more people working on the same environments, bigger teams, the benefits grow super linearly.
So it's like a exponential return on Mirrord, right? So you've seen the graph for exponential, right? So you still get benefits if you're a team of 3-4 developers, but as your team size grows, the value of Mirrord really, really starts to shine, because that's when you start to hit those and usually when your team size grows, your application also starts growing, more in complexity. Now, sure, if you're building a 1 or 2 microservices based applications, you can argue that there's not a lot of benefits to using Mirrorly because you could run things locally or in containers. But when you start to add more microservices and your team size starts to increase, you start to hit all the challenges we talked about in this webinar, and then Mirrorly just really becomes like sometimes a no-brainer to adopt.
Cool. That's awesome. Uh, so if anyone have any questions, please feel free to reach out to us and Tal. Do you have any resources where they can reach out to you later if they have any questions?
Yeah, like I said earlier, you can find us on our community Slack, and I'll share that link with you. And you could add it in the chat, and that'll be really helpful. So if you want to talk to us, you can find both Tal and me on this particular Slack. But if you don't want to join Slack or still want to ask questions, we have a Discord community, or you could just find Tal on me on LinkedIn and send us a message there. We also have one more resource. If you would like to, learn more about Mirrorly, see what it's about, I've sent you the link for the website, and there you'll find the link for the GitHub project. It's an open source project, so you could try it out. You'll find different companies who are already using Mirrorly. You could read their case studies and see what benefits they've seen. But yeah, you can learn more about Mirrorly on this website. And if you want to talk to us, you can join our Slack community.
Cool. Thank you, Ars and Tal, for a great presentation. And thanks everyone for joining this latest episode of Cloud Native Live. We hope you enjoyed the interactions and questions from the audience. Thank you for joining us today, and we hope to see you again soon.
Thank you very
Yeah,
much.
thank you for being an amazing host, and thank you for everyone who joined from different time zones and was with us.
Bye.
Bye,
See you
chat.
all. Bye.
Bye.